Hello, welcome to my channel. In this video, we will continue on problem number 6 on the curvilinear motion. So, what you see here on the bottom left is the industrial robot schematic that rotates about a fixed point O and can extend or retract as the position A and P is assigned. Okay, so at the instance shown here, the condition is given as follow. The question gives us theta equal to 45 degree, theta dot equal to 1.5 radius per second, theta double dot equal to 1 radius per second square. Okay, the dimension of the position OA and also the increasing rate of the arm OA dot equal to 0.4 meter per second, and the acceleration of this OA is also given as minus 4.5 meter per second square. So the question asks to determine the magnitude of the velocity and acceleration of point A at the outer end of the arm. Okay, so firstly, I derived the point A as a reference axis as always. Then distribute or what's it called, the assign the velocity on axis theta and v theta, velocity on axis radius at vr. Now to determine velocity vector v, we have to interpret the value that's given here into the radius information here. Then we call out the velocity vector as r dot times er plus r theta dot times e theta. Then we obtain the velocity vector as shown here. Okay, simple enough. Moving on to the magnitude of this velocity. Okay, we just square the component and the square root, we get 2.41 meter per second as the magnitude. Okay, now if we look onto the acceleration, then recall the general equation of the acceleration here. Substitute the parameter shown here. Then simplify version is equal to 6.75 ER plus 2.2 E theta. Again, the magnitude is also determined by the component square summation under square root equal to 7.1 meter per second square. Now, this is the information on point A. Okay, so as a homework, I would like you to think of the velocity vector and acceleration vector. I want you to determine those, but this time not point A but in point P. Okay, we already know the information on point A, right? So to be able to determine the same thing in point P, I think it's very more or less possible. Okay, so as a given hint for you to try to figure this homework, if it was me, if it was me, I already know that in point A it can move forward in this r-axis. So in that moment on, this P here, by P here, from A to P is constant, meaning that the direction and displacement of A to P will be the same. So given if this arm here was then, let's say if, for example, it was shortened this hand here, and then point A was moving downward here, that means the point P should be around this point. Make sense? So Firstly, what I want you to do as a homework, I want you to try to firstly uh, determine the position of point P. Okay, determine the position of point P. Let's say after 1 second pass. Okay, after 1 second pass, given this is original position 2 equal to 0, this is or this schematic is referring to the initial position. So after 1 second, I want you to find out what P will be on X and Y coordinate. Okay, that's the first problem. Now, the second one, if you can, try to find the velocity of point P, and then if you can do that, verify the acceleration vector of point P. Okay, so it's very interesting and question you can try on yourself and see that this and for the later video, not next one, I will show you the complete solution of this extra homework I'm giving. Anyway, try to figure out by yourself. If you want to have some hint or some checking, you can comment down below and I will get to you as soon as I can. Thank you so much for watching. Please try this interesting exercise. Okay, thank you. I'll see you on the next video.